Alright, we're going to look at segment lengths. We did angles, now we're looking at segment lengths. We have three different ones we're going to look at today. Intersecting chords, intersecting secants outside the circle, intersecting secant and tangent outside the circle. So, if it's inside the circle, it's just the parts. A, which is here, times B equals C times Z. You just multiply the parts together that are on the same segment and they equal each other and solve. Now, secants outside the circle. It's A times this whole thing, which is A plus B, and C times this whole thing, which is C plus D. Then, same thing with the type 3, our intersecting secant and tangent, except there's only one thing here, so it's A times A, or A squared, equals B times this whole thing, B plus C. So those are the formulas or equations we're going to deal with. So we're just going to look at a couple of these. Number one, well, it's a chord-chord angle, or chord-chord segments. So 10 times x equals 14 times 15. So 10x equals 14 times 15, that's 10x equals 21. Divide by 10, x equals 21. Pretty straightforward. Number 3, same thing, 24 times x plus 7 equals 27 times x plus 5, but now we need to distribute. We had 27x plus 135 equals 24x plus 168. We subtract 24x from both sides. We get 3x plus 135 equals 168, minus 135, 3x equals 33, divide by 3, x equals 11. So that is your type 1, where intersecting chords form these lengths. Now let's look at 5. This is our secant-secant. So it's 9 times the whole thing, which is x plus 9, and 8 times the whole thing, which is 8 plus 19, which is 27. So now we distribute over here, and on the right side we just multiply. So we get 9x plus 81 equals 216. Subtract 81. We get 9x equals 135. Divide by 9, x equals 15. Next one we're going to look at, number 8. Now we need to find yz, not just what x is, but the segment yz. So it's 12 times the whole thing. 12 plus x plus 8 simplifies to x plus 20, and that's what we have here. We do the same thing on the other side. 15 times the whole thing, 15 plus x minus 1, which is x plus 14, and that's here. So we distribute. We get 15x plus 210 equals 12x plus 240. We subtract 12x from both sides. We subtract 210 from both sides. Divide by 3, x equals 10, but it wants yz. So yz is 10 minus the 1, or x minus 1 equals 9. And that's how we get that. Another example like that, number 9. Oh, no, number 9, we go into the tangent secant, where it's this one, which by itself, the tangent, 24 squared, equals 18 times the whole thing, 18 plus x, or x plus 18. Distribute the 18. We get 18x plus 324. 24 squared is 576. Subtract 324. We get 252 equals 18x. Divide by 18. X equals 14. Another one like that. So this one's by itself, 3x squared. So it's the whole thing, 3x squared. Notice there's parentheses here, because we want to square the 3 and the x. And then it's 9 times this whole thing, 9 plus 16, so 25, and that's what goes there. So 3x squared is actually 9x squared equals 225. We divide by 9. We get x squared equals 25. Take the square root. Now usually it could be plus or minus 5, but if we plug in a negative 5, we have a negative length here, so it's just x equals 5. Now we're going to look at some ones where we have to multiply and we have to factor. And I'm going to switch my color. Number 13. Again, it's x plus 6 times x plus 1 equals 12 times 10. So this is our chord. 12 times 10 is just 120. X plus 6 times x minus 1, we have to either do the box, I'll do the box this time, or you could FOIL or double distribute. So x times x is x squared, x times 6 is 6x, x times 1 is 1x, and oops, that's a negative 1, so that's negative 1x, and 6 times negative 1 is negative 6. These two are like terms, they add up to be 5x. So we get x squared plus 5x minus 6. So we have a quadratic. How do we solve that? Well, we get it all over on the one side, so we subtract 120. We get x squared plus 5x minus 126x. So what we're going to do is do our diamond problem. Negative 126 and 5. What multiplies to negative 126 and adds up to 5? Well, 14 and negative 9. And because our coefficient of x squared was 1, we can skip right here. Then we set each of those equal to 0. So we subtract 14, so x equals negative 14. And we add 9. X equals 9. Obviously, x can't be, or segments can't be a negative distance. And when I plug in negative 14 here, I get negative 15. So that can't be it, so it's just x equals 9. 16, same type of thing. It's x plus 5 by itself, the tangent, so x plus 5 squared equals 12 times the whole thing, 12 plus 15, which is 27. So 12 times 27 is 324, x plus 5 squared. So it doesn't mean you distribute the 2 in, you write it twice and you distribute then. So x times x, 5 times x, 5 times x, and 5 times 5. We combine our like terms. That's how we got here. We subtract 324, get everything on the same side. That's how we get to this next step. And now we got to do this tough diamond problem. Negative 299 and 10. What two numbers multiply to negative 299 and 10? 23, negative 13. Again, coefficient is 1, so we can skip right here. Set each one of those equal to 0. Subtract 23, x equals negative 23. Add 13, x equals 13. But again, the distance can be negative. If we plug in negative here, negative 23, that wouldn't work. So our answer is just x equals 13.